Okay, so there's really two ways I can look at this. I can start out with small values of x. Is that on screen?
Mm-hmm.
And I can just compute 2 to the x minus 1 over x. So the limit as h goes to 0. So when x is 0.1, I can get 0.71 for 2 to the x. And I get 0.695 as I shrink x down here. Or there's actually a limit function in Mathematica, which probably is not all that surprising. And we, if I want to do 2 to the x minus 1 over x, looks like I'm missing a parentheses there.
You still have x set to 0.001 up top.
Ooh, good point. Thank you for figuring that out. I was puzzled. So the way you do that is you clear x. Oh, no. Shoot. What does the limit equal?
It's log, well, it's ln of 2.
Okay. Oh, I don't like that. I didn't want to give away the answer by accident. So let's play up here. 3 to the x, I get 1.09. Why don't you play with some numbers?
Well, you can check like, oops, like maybe 4 for 5, I guess. You can check E, which is, that's EXP.
Yeah.
Like that?
1, exp 1. So you have to do exp bracket 1. Okay.
Well, that's very close to 1.
Yeah. Check 2 again.
2. Oops.
Yeah, so I get 0.69.
Yeah.
315. Now check a half.
Negative. What we got for 2? Well, 1/2 is 2 to the minus 1, so maybe by the chain rule, we're getting something.
Okay, so 2 to the x is the same, or 1/2 to the x is the same as 2 to the minus x. So yeah, that's a good guess. But my limit, my unbroken limit, when I clear the x value, actually tells you exactly what the right answer is. So 2 to the x, this limit produces something that's smaller than 1. Three to the x produces
Should be bigger.
somewhat bigger, and why don't you try to sort of find where it equals 1?
So
See if you can.
let's check like 2.5. Close. 2.75. Oops. It's a bit over. 2.725. Still a little bit over. 2.7. 2. 2.71. Now we're a bit under. 2.715. 2.716. 2.717. 2.718. And then that's where we go over. So, and this is close to E.
Yeah, it sure is.
And then 2.71828.
Yeah, you accidentally put 2 8s in there.
No. It's very close.
Yeah. So one way of defining E is to say that E is the value where this limit equals 1. And the reason we were looking at this limit is it comes up in the derivative of exponential functions. And this derivative at 0 multiplies the derivative everywhere else.
Mm-hmm.
So e to the x is the function, so that the derivative everywhere is what?
Is 1 or not 1? But e to the x minus 1?
No, let's go back to what we were talking about before.